Yeah. All right, all right. So welcome everybody. Welcome to the community meetup. The February community meetup, to be precise. Oop. So we gotta shortly get started. Welcome everybody to the Suborbital community meetup. My name is Flaki, which is a short version of Istvan Swarzynski. And we have these recurring meetups to the community meetups every week, every month at the last week of the month, last Tuesday of the month to be precise, to bring you information and news both around like Suborbital and cloud WebAssembly, but just also just like the ecosystem and the Suborbital itself and the tooling and contributors and stuff that we have been working on. So hopefully you're gonna enjoy today's call. We have a recording ongoing, so you should be able to if you heard something like cool or interesting, you should be able to send it over to folks who missed it. And I should also note that we are preparing, like everything that you see here is like a sneak peek, and we are going to have next week a kind of tiny release week where if some of you were around on like November when we had like a big release week for Suborbital, like we're gonna have like a tiny release week next week when some of this stuff is going to show up for the show gonna go live for the community. So and consider this like a kind of early showcase. So what are we going to talk about today? One of the things I'm going to start off with talking a little bit about our new Suborbital docs that we are going to replace the documentation of Suborbital with a completely brand new one and consolidate all our documentation into one place. And I'm going to show you a little bit of sneak peek into that. After that, Nyah Macklin is going to join us, who is going to showcase the new create handler command that they created for the subo CLI. And encourage you all to contribute to the open source Subo CLI. That is like one of the cornerstones of our suborbital like architecture or infrastructure, both the open source ecosystem and our paid products as well. And last but not least, Oscar Spencer is going to talk about using JavaScript and TypeScript in a Reactr and like everywhere in the suborbital ecosystem. If you have been around and like seen our tweets recently, like this is gonna blow your mind. Like there is some really cool stuff happening like at the intersection of WebAssembly and Rust. So be sure to stay tuned for Oscar guiding you along this, and he's going to tell you when you yourself can be trying this out and playing with these JavaScript and TypeScript in Reactr yourself. So without further ado, let's dive right into it. Let me switch over to, I want to showcase y'all the brand new documentation that we have been working on for Suborbital. So what you see here, and like I'll ask somebody to post the link to the community chat. So suborbital.github.io/docs is the preview of our upcoming documentation, or rebuilt documentation site. This is going to replace docs at docs.suborbital.dev, which and going to bring together both the suborbital SDN, suborbital compute documentations, as well as Atmo and some of our upcoming products like SAT. Like you're going to be hearing a lot more about SAT next month. We have a lot of cool things planned for SAT. But you can already check it out, the documentation. So I'm just gonna go into like the Atmo docs here. So as you can see, both compute, Atmo, stat, and a bunch of the building blocks, Reactr, vector graph, the underlying building blocks of the Atmo and the suborbital ecosystem, you will find right here, as well as completely rewritten API and documentations. So what you will see here is like you will be able to access the Rust assembly script and Swift documentation right now, and we are also working on getting the brand new JavaScript, TypeScript, and Grain docs in here as well. Oscar is going to tell you a bit more about like when those are coming and what you can expect here, but you should expect those to drop here as well. And important to note that I just realized we had the music on. I hope it didn't annoy you all too much. All right, sorry about that. So another thing that that you're going to be able to see in the documentation that we have planned is like full-blown examples and tutorials coming up for using Atmo, and both in itself and like with a bunch of our partners. So how to deploy Atmo like with your preferred cloud provider, and like how to interoperate with your existing systems. So we're planning a bunch of stuff to come here as well. More importantly, one of the reasons we are also giving you this kind of sneak peek is for you all to be able to check out the suborbital, because this is completely open source. You will be able to file issues if you find any problems or missing things in the documentation. You can absolutely go to, again, like somebody could post the link, github.com/suborbital/docs, which is the GitHub repo for the suborbital logs. Now, for if you work in React or JavaScript in general, you could contribute to improving the documentation website itself. Like there's still a lot of outstanding stuff and things of improvements that we have planned. So you may as well contribute to the website's like layout and like workings and infrastructure itself. But you can also just file issues here about some of the some of the problems that you have found and some of the problems that you have noticed. So you can already see like there's a bunch of issues found, and we are working through uh, slowly all of these issues like in the future. But we're also welcoming contributions. So if you are interested in if you find an issue, just find a problem on the documentation website. Just file an issue here, and if you kind of feel like it, feel free to let us know that you would be interested to take on that issue, or send a pull request as well. If you wanted to contribute to the documentation, we want to make the docs very accessible to our community, and so we want to make sure that everybody gets to contribute and improve the documentation. Again, like this, all the Atmo and component ecosystem that the building blocks of Reactr, Vector, and Graph takes its documentation from here. So you're contributing to all of these underlying open source tooling. So that's the short of it. Stay tuned for updates and the release date on finalizing this this work. But also you can already access it on the URLs before. And so here's where we go on to I guess I should ask if anybody has any questions or any anything maybe from the chat. I'm asking perhaps Ramon. Nope. I'm just gonna check the chat real quick. Okay, I don't see any questions. All right, feel free to drop any questions. Like we can answer them later as well. But we can blaze on, and I'm gonna invite Nyah onto the stage. Let's have hello there. So Nyah is going to talk about the comment that they worked on for the CLI. I'll just ask you to. Oh, there we go. I'm gonna remove this.
No problem.
And just gonna make you. All right, take it away, I guess.
Okay. Sweet. All right. Well, thank you so much for having me. Welcome, everyone. Good morning, good afternoon, good evening, and good night. Thank you so much again for joining our call today for the community meeting with Suborbital. Woo! So my name is Nyah Macklin. I'm an engineer here at Suborbital, and my pronouns are they, them, theirs, if you ever want to refer to me. So I wanted to do just a really quick poll, and feel free to type in the community meetings chat here in Discord or in Streamlabs if you're watching that way. But I wanted to ask who here has never, if you've never contributed to open source or Suborbital's open source before, what do you think has been a barrier to you doing so? Poll time. Yeah, feel free to write down in the chat, community meetings chat. Ooh, okay, we got some people typing. Love it. If you've never contributed to open source, what was your barrier? And while folk are typing, I can tell you about my barrier. As a developer throughout my years, I actually had never contributed to open source prior to Suborbital, right? Like wild. And my barrier was first like not knowing where to start, right? You see these plethora of open source projects possibly on GitHub, and you're like, where do I start? Do I do a huge feature? If not, like, how do I even make my first open source contribution? And I had no idea where to start. Another question for you all is for folks who have contributed to open source, and specifically Suborbital's open source, what was the most exciting part about that? Like, what was super fun? And I know there are a few of y'all who are in here who have contributed to our open source projects. So if you have, please feel free to throw it down in the chat about what was really fun about contributing to that feature or that doc. Anything that you have, throw it in the chat. And we have some awesome responses. I've made a couple of extremely minimal contributions to open source, totally cool, go gadget, and have contributed more and earlier if I had been clear on how to start. Great point. And Ramon says, it took me a long time to get started contributing as I was intimidated and afraid of stepping on folks' toes. So real, all right? So this conversation that we're gonna have today, we're hopefully gonna make sure that you feel confident and feel ready to contribute to Suborbital's open source projects. We have so many, and we wanna make it welcoming and available to you in any way. So that's my job today, and I hope that I achieve it. So come on this journey with me. Okay. So keep typing, everyone. But again, like I said, prior to Suborbital, I had never contributed to open source before, and I always wanted to. And so today, I'm going to tell you how I went from never contributing open source ever before to taking a really small idea and pulling it out into a fully fleshed out feature for Suborbital, right? Which has improved and will improve the developer experience for all of our users. Yo, like we just trying to do some great work here. All right, so I'm going to tell you all about working within Subo, which is our command line interface, Subo. So how I coded out the create handler terminal command for Subo. So if you've never heard of Subo before, Subo is our command line interface that powers the development of Suborbital, right? So it allows for our users to build, to package, and deploy cloud applications. Dope. So enough about that. Let me show you how it works. Boom, boom, boom. Cool. All right, I'm gonna thank you, Flaki, for bringing up my screen. Sweet. All right, so I'm gonna go into my terminal here, and I'm gonna show you just a quick little demo of how Subo works. So we're gonna go expand our terminal. I'm going to create another terminal. We're gonna go to Subo, and we're just gonna type in Subo. Once you have Subo downloaded, of course, you're gonna type in Subo, and you can just press enter. And this tells you all the information about how you can use our CLI, what Subo is, any of the available commands that we're going to use as well. This is really helpful for any help that you're going to need when using our CLI. So, all right, so we have all this information. So you'll see this subo create command. And as you can see, subo create is a runnable subo create, that command allows us to create a runnable project or a handler. So as I mentioned a little bit before, we're actually going to be creating handlers today. So, and don't worry, I have my notes because I'm a little nervous, so bear with me. But a little bit of background on the problem that I was solving here. When our users were building applications in Atmo, so Atmo is one of our other open source projects. In Atmo, the user will come, when they're building applications in Atmo, the user will come to a point where they have to edit what's called a directive file. Now, if you've never seen a directive file, I'll show you quickly. I had never seen a directive file before either. So really, all the work that I've done before, please know that it's accessible to you as well. And thank you for pinging to our Atmo repo. But so here's a directive file. And to give you a background, a directive file is just a declarative file that allows you to describe your app's business logic, right? So it's really, it's directing what your app's business logic is going to be. So you'll see the directive file here in Atmo, it has lots of different components. You'll see authentication, which is specified, as well as the Atmo version that we're using. Again, we're in the Atmo repo. And then you'll see that we'll also have handlers here. So a user, when they're building projects in Atmo, our user has to come into this file and actually handwrite these handlers. That's whack. Like, who wants to do all of this? Who knows all of this information that they're going to have to put into it? And it just creates another barrier, I think. So that was the big problem that I had to solve. How do we automate this process and make it much easier and simpler for our users? So to specify, what's a handler? Like, what is that? So a handler is actually just logic that tells Atmo how to handle a particular resource. And by resource, I mean a particular endpoint. So you'll see that this resource here is specified as -hello. That'll be an endpoint in your URL when you're building out your Atmo application. And so this handler is just telling Atmo how to use this resource. So your handler in this case will always require, in Atmo, it will always require a type. All right. And a type is a kind of input that's a type of input that's being spelled out here. So for example, this type is request, and request, the type request has an HTTP request as our input here. And your handler will also take a method. And so your method is like get, post, put, and delete, for example. And then it will always require the resource that you're specifying. And the resource, again, is the input that Atmo makes available through our HTTP endpoints. Cool. All right. So showing you a little bit about the directive YAML. That's enough talk. Let's actually get into it. All right, so if you're starting from scratch or you don't have Atmo downloaded, and also if there are any questions, feel free to stop me at any time. I'm happy to answer them throughout this conversation. And you can feel free to type them in the chat as well, and Flaki will stop me. Sweet. All right, so if you're starting from scratch or you don't have Atmo downloaded because it's a hassle, and it's not. But if, for example, you just don't, you can run this command here. It's called subo create project. Subo create project. And then you can actually press enter. So you'll see that subo create project is going to tell you that it has an error because we need to create a name for that project. So this is just one example of the ways that you can use subo if you just want a quick and dirty way to access the subo CLI, for example, and create the project that you're going to need here. So you can run subo create project. You'll include that name. And that will create the example project so that you can then use the create handler command that I'm going to show you a little bit about in just a couple minutes. So I already actually have an example project that's already created. So I'm going to move on over to, it's created in Atmo. So I'm going to move back over to Atmo, and I'm going to cd change directory into that example project. Sweet, we're in. And then I'm going to run subo dev. And running subo dev here is actually just going to create a development server for subo so that we can run our command. So we ran subo dev, it's running. Now let's go to a different terminal because we don't want to interrupt this development server. We're going to go to a new terminal. That terminal is going to be in subo, and we're going to run make subo. Sweet, make subo is all set. All right, so we've run make subo. We have our development server from subo dev already running. So in this same terminal, we can now cd change directory. We're going to get out of here, go into Atmo again, go into our example project. Perfect. Now we're back. So now that we're in our example project, this example project that I have, again, is it already has the directive file created in it, and that's one of the most important parts to running subo create project. It'll give you that directive file that you need to edit in order that you would edit if you didn't have the subo create handler command that we're going to be using today. But you need a directive file, period, in order to work with this. So we're in this directive file. We're in the subo example project. And then again, I showed you all just a little bit about what that directive file looks like. Another reminder, the handler is just logic that tells Atmo how to handle a particular resource. So these handlers is just business logic. And so in other words, it tells Atmo what kind of endpoints that we can access via the server. All right. So we're going to go over here and I'm going to actually show you a little bit about what that create handler code looks like. All right. So it can look like a lot, right? It can look like a lot. And actually, don't be overwhelmed. Don't be overwhelmed. Remember, I was brand new to this and I had never seen a lot of this work before. Also, I've never coded in Go, right? Go is brand new to me as a developer. My background is actually in JavaScript. So for those who have backgrounds in other languages, Python, Rust, or any other language, for example, and if you wanted to create a feature within Subo, just like I did, I had a really great experience learning Go, and I actually think that it was relatively intuitive, which is like, wow, like really, like actually intuitive. Because at first when I read all this, code that looks like this, I was like, I don't know what's happening. But in the process of creating this this command, I was able to learn more about the Go language, and it really helped me better understand how best to create this command. It's a lot, but important parts. We're going to focus on the important parts here. You'll see here for this create handler command that we're using this thing called Cobra. What the heck is Cobra? If you've never heard of it, thanks for the support in the chat. If you've never heard of Cobra, Cobra is it's actually a library, right? So Cobra's a CLI. It's a library for creating CLI applications, and it's a program that allows you to generate applications and command files. Perfect. Why don't we use Cobra? That's exactly what we did here. So just so you know, Cobra is Golang based, so it's based in Go. There are actually some really famous projects that use Cobra itself. So if you've heard of a thing called Kubernetes, boom, Kubernetes actually uses Cobra for their CLI. And if you've also heard of Git, I know a lot of us use Git for Git. GitHub, their CLI uses Cobra as well. So lots of different aspects, lots of different awesome projects are using the same code that you're writing here. If you were to create a feature for Subo, and specifically a create command feature for Subo, you can use something like Cobra, which seems to be industry standard, which is pretty dope. Okay, so we're using Cobra here, and you can see that we're taking in whatever our argument set. So once we press create handler, once we write subo create handler, we're going to take in the name of whatever the resource is. And remember, the resource is the endpoint that we have. So let's actually see what that looks like. Like, why not? All right, so we're in the example project right now. Let's go back to Subo. So we're going to run Subo. Subo create handler, and then we're going to put a name for that resource. So we're going to make sure that we put our slash, because this is a part of an endpoint, slash community meeting endpoint. We're just going to name it something random. But I want to do, before I press enter, I want to just minimize this, because remember, this is automating what's going to be happening in the directive.yaml file. So let's scroll all the way to the bottom of our directive YAML, and I want to see you guys. I want to let y'all see what this is going to do to that file in real time. So we see this, the last handler that we had created, I created this before this call, was of type request and a resource fake new one. So once we press this, we should have a handler that appends to the bottom of this page that will have the name / community meeting endpoint. Oh, error, cannot create handler. Oh, haha, we did it in the wrong, Lord, words. We did it in the wrong repo. We have to do this in Atmo. So we're going to go example project. Perfect. We're going to run this. Boom. Yes. Look at that. Golden. So we created it. We'll see by our log, start creating the handler for community meeting endpoint. Done. And then letting you know that an upgrade to Subo is available if you want to download it. Sweet. And you'll see right here in the directive YAML, it has updated. So we have the type request and the type get. Because we didn't set these, they're actually defaults that we have within the create handler command. You'll see if we scroll down to the bottom, we have some defaults that are specified, default request and default get. But then we have our resource, community meetings endpoint. And it's all set, and this is an automated process now. Okay, so last thing here before I get off, improvements to this. As you can see, we don't have our steps specified here. And that can be another aspect of the handler. So this is an awesome way for you all to get involved in creating, in helping with our open source projects. If you're interested in thinking about what does creating steps look like, and I'll show you a quick example. You'll see that steps actually pretty much just tells us what functions are going to be running in our application. So you'll see steps, it'll have the function, it'll have as, for example, the function, what you're going to call it as, and then with, for example. So lots of space, to build out what this looks like, and really excited to be working with you all as well. So let me know if you need anything, and that is the end of our call. I hope you enjoyed learning about the create handler command.
Well, at least at the end of this part of the call, because we still have Oscar upcoming. But yeah, that was amazing, Nyah. I'm like, wow, I seen you do this like once already, and like I was like, there's no way they can do better than that, and they could.
Yes, thank you, fam. Appreciate y'all.
I don't really see a whole lot of questions. Like, folks, keep the questions coming if there's any questions. Also, please check out the Suborbital Subo repo if you ever got like a kind of pique your interest to contributing. I can't. I'm not sure. I'm not sure. Sorry if you actually mentioned it. I might have missed it. But also, like, stuff like Cobra is used by a bunch of other Go projects, for example, all over the place. So, and another, great opportunity to get some open source contribution jobs and, learn a bunch of new technologies for yourself. Right? I don't see any questions, but like, Nyah is going to stay with us, and we're going to be able to come back for questions later on if there are any. Thank you again, Nyah. This was wonderful, amazing, and let's hope we'll hope to have you back like for other features and stuff as well later.
Anytime. Glad to be back. All right.
Alrighty. Bye bye. Alrighty. So I guess. All right. Please keep the questions coming. Also, feel free to just hang out and chat in the chat. That's what the chat is for. Keep the hype coming, I guess. Like this is our kind of initial first version of like the community meetings. So something that we are actually looking for is feedback. you liked something, you didn't like something, like feel free to either drop them into the community meeting chat, or ping me directly in Discord. That will also work. Or find a way to share feedback with us. Because we are still iterating on the format uh, on how this is going to look like. Uh, so yeah, so Denupik is asking if we want questions for why the chat or voice chat. I would guess let's leave the voice chat like closed for now, as long as the talks are going. But like you can always put your text questions into the text chat while the talks are going, and I'm happy to convey them. Even mid talk, like I'm happy to ask them, from our speakers. So feel free to interact with our speaker through the text chat, and like later on we can we'll open the floor in the voice chat as well. So you will be able to talk with the engineers and developers as well. So yeah, please share your feedback. We're still iterating on the process, and like there's a bunch of stuff that we still want to do. So if you would like to see something in these community calls, or like didn't like something in the community calls, then just let us know. And so like here's the time that I'm gonna be inviting Oscar on stage for the upcoming talk about letting us know about React and JavaScript and TypeScript in Reactr. So, uh, yeah, there we go. Hello, Oscar.
Hey, how's it going?
All right, it's going all right, I guess. Thank you for presenting your like deep dive into the bowels of technology for us today. Like, I hope it's gonna go all right. Oscar has been having a bit of a nausea earlier today, so please forgive us if something doesn't go as expected. But yeah, I'm without further ado, like I'll give you the stage. Looking forward.
Thank you so much, Flaki. And yes, if folks have absolutely any questions at all, please throw them in the chat. Flaki will definitely interrupt me. But yes, my name is Oscar Spencer. I'm the Director of Engineering for the compute product here at Suborbital. And the thing that I've been working on recently is getting JavaScript and TypeScript support into Reactr. For those of you who aren't super familiar with Reactr, it is our WebAssembly function scheduler that powers Atmo. So a very critical part of our platform. And sort of folks have been asking left and right, hey, you've already got all these languages. You've got Go, you've got Rust. Like these languages are awesome, but is there any sort of way we can get JavaScript support inside of Reactr? And like this is sort of an interesting thing, right? When we think about JavaScript and we think about WebAssembly, we always heard the story that these two things are supposed to go hand in hand, right? They're supposed to be working together. WebAssembly was never meant to replace JavaScript, things, of that nature. And so, of course, it really begs the question, why on earth would you want to run JavaScript inside of WebAssembly? And I think the major thing that we have to think about are really all of the things that WebAssembly gets us in terms of its sandboxing properties. So, as you all know, when you're writing an Atmo project, you've got a number of capabilities that you're allowed to turn on and off at will for what your functions are allowed to do. And so when WebAssembly code is running in its WebAssembly sandbox, we can very finely tune exactly what that code has access to. And that's not something that we would be able to do if we were just running Node.js or even a Docker container. Especially if you look at JavaScript running inside of Docker, for example, that JavaScript code is allowed to make whatever host calls it wants. If it wants to access the file system, if it wants to access networking and things like that, it can just do it. And of course, you can definitely go and try and turn off all these things. You can say, oh, let me not give it access to parts of the file system I don't want it to access. Let me try and block certain ports and things like that. But at the end of the day, you definitely are going to forget something. You're going to forget something that's left open that code's going to be able to access. But with a WebAssembly sandbox, this isn't the case. We're starting from a blank slate and we're adding on capabilities as things go on, which is quite nice. So I want to talk you through sort of a little bit of a very deep technical way of how we got JavaScript running inside of WebAssembly. So let me go ahead and share my screen here so you can see some code. Here we go. Cool. Awesome. So this project here is called Javi. This is a project that our friends at Shopify pioneered, and it's essentially a JavaScript runtime. In this case, it's Quick.js, which is inside of Rust. So inside of some Rust code that all gets compiled down to WebAssembly to run as a single self-contained WebAssembly module. A self-contained WebAssembly module that's executing your JavaScript code. It's got no external dependencies. It doesn't need to run in any special environments. It's just if you support WebAssembly, you can execute this thing and you're all set and ready to go, which is absolutely awesome. So what we did was, we took this, we adapted Javi a little bit to sort of work with, Suborbital, our platform and whatnot, which was absolutely excellent. But we wanted to maybe go a little bit of a step further. One of the things that is a little bit of a struggle in terms of trying to actually use, JavaScript code inside of a WebAssembly environment is getting access to host functions. So these are sort of functions that your WebAssembly runtime is providing you for your code to use to do things like access, file system, networking, system clocks, all that good stuff. And that's the tricky bit. Of course, this Javi project, it's awesome. It has a way for us to create, functions inside of JavaScript, those JavaScript closures that we're able to call into and call these functions. But it still is quite a bit of effort to write these by hand. It sort of takes a lot. However, one of the things that's very neat in the WebAssembly ecosystem is the emergence of WebAssembly interface types. Now, this is one of those projects that gets me super duper excited. It's still a proposal, right? Interface types aren't completely implemented yet, but the whole idea of interface types is to provide a clear way for different WebAssembly modules or WebAssembly modules and hosts to interact with each other and pass data back and forth. And so what's kind of interesting is we have a project that exists. It's called WIT-bindgen. So it's WebAssembly Interface Types of Bindgen, which can generate a set of language bindings. So sort of like that glue code that can go about translating between your languages types and the actual WebAssembly types. And so this WIT-bindgen project does exactly that for a number of languages. It supports Rust, it supports C, and importantly, it supports JavaScript in the browser. So if you want to be able to interact with the WebAssembly module in the browser, you can use the WIT-bindgen project to say, hey, these are the function interfaces that I have. Just generate some JavaScript code that can talk to this WebAssembly module and do things like pulling strings out, for example. So in WebAssembly, generally, most strings we use are like UTF-8 encoded. JavaScript is not UTF-8. JavaScript, for example, uses WTF-16, and I'm not making that up. That's really what it's called, as it's as it's string encoding. And so this WIT-bindgen project is able to create that translation layer to actually go back and forth between the WebAssembly and JavaScript. So I was sitting on a call with the Shopify folks, and I thought to myself, wouldn't it be incredible if we could use that project inside of Javi, this project, to actually generate all of those host bindings so we can just use them inside of the JavaScript. So I actually want to show you, I hate to show you all some gross macro code, but I was really excited by this. I put together this macro that essentially you can just tell it, hey, I have these host functions that I want to bind to from my JavaScript. Just go ahead and create those JavaScript closures for me to use. So I'm not going to bore you through talking you through exactly how this macro works or like the different pieces of it, but I'm going to scroll down a bit to where it actually gets used. Let me make this a little bit smaller here. But there's this like function called setup imports, which sets up imports into the JavaScript code. And we could just call this macro. We can say bind imports and say, hey, here are all of those host functions that we want. And these are all the things that Reactr supports. So logging, doing network calls, accessing caching, whatnot. We can just say, hey, these are the host functions, and just generate JavaScript functions that can straight up just call these, no problems, no questions asked. In fact, I'm going to scoot on over here because I want to show you something that's pretty cool. So we can actually see this generated code. So in this case, being able to set into whatever cache we have or whatever, we need to do things like I said, do that translation step between JavaScript strings, which are not UTF-8 to UTF-8 strings and whatnot. But this is all code that gets generated by WIT bindgen. And so what this means, of course, is yes. On the JavaScript side, we are actually dealing with raw pointers to strings and things like that. But the good news is WIT bindgen takes care of all of that for us. We're not actually going in and worried about having to deal with these pointers and whatnot. WIT bindgen actually takes care of that for us by generating all of this code. But this was really, really neat. And so what this means is we can actually contribute a lot of this backup upstream. So for anyone else who wants to use JavaScript running inside of WebAssembly with their particular, runtime or, whatever they want to use, they'll be able to just use, this macro. They'll be able to say, hey, yeah, actually just create bindings to these functions that I have. So a good example of this is there's a WebAssembly runtime called WASM4. It's like a game engine, for example, and they've got a number of host functions to control different inputs and things like controllers and whatnot. And those folks can just use this. You can just say, hey, bind all these things, and instantly from your JavaScript code, you're able to actually use all of this. So this is super duper exciting. I'm super excited by it. We're actually planning on taking it several steps further, where instead of having to use this and supply, all these, functions and say, oh, create these bindings, we want to be able to just supply a WIT file and say, hey, here's a WIT file, go generate all of this for me, inject all the JavaScript code, don't even make anyone use that in the library. And it's actually going to be truly incredible. So we're super excited by all of this. But of course, I know you all want to see us actually using this stuff. So yeah, let's use it. Let's put my live demo skills to the test. So I'm going to go ahead and create a new runnable. So we're going to do subo create runnable, 2 N's. Subo create runnable. In this case, let's call it fun because I think JavaScript inside of WebAssembly is very fun. And we're going to pass the --lang flag. In this case, we actually decided to support both TypeScript and JavaScript. So you can do --lang TS or --lang JS, either or. In this case, I'm going to do TS. And boom, we've got our new runnable here in TypeScript. And so here, it's very basic. It's going to look just like every other runnable that we've got of, it's a normal run function, takes an input. You can do some stuff and do an output and whatnot. Let me cd to that folder. Let's go ahead and get this built. So I'm just going to run sudo build dot, just so that way we have a little bit of a baseline function that we have here. Of course, we want to have our libraries and whatnot. We want our editor to get working. This will go ahead and install this library, give us our TypeScript types and everything, so we can have a pretty good time there. Now, what's pretty fun about, the JavaScript support is that, we can use absolutely everything in the JavaScript ecosystem that we want to use. So in fact, while we're building this here, it's doing normal stuff. It's using Webpack, it's like, hey, I want you to bundle this for me using Webpack and whatnot. We end up running Javi to generate that WASM file for us. But yeah, we end up getting this WASM file right here that just is completely self-contained. It contains all of this, beautiful JavaScript code here. I'm actually going to show you guys this working using our sat project. So I'm just going to run sat fun.wasm. And so sat is, our tiny little WebAssembly runtime. It's just a wrapper for Reactr, but it's super tiny. It's great for testing out little runnables just like this. But I've got it running here. We're running on ports 3030. So let's go ahead and hit that. So I'll use curl. So curl localhost 3030. We got to pass it some data. In this case, it's going to be hello plus whatever data we give it. My name's Oscar, so I'm going to pass it Oscar. And yeah, let's do that. And cool, our JavaScript runnable works. It concatenated a string. That's cool. That's fun. But it would be a lot more interesting if we were doing something a little bit more complex. So with the library that we have here, of course, let's take a look at HTTP. So let's bring that in and let's do a HTTP call. Let's say let text. So text is going to be HTTP dot probably get. That's a good one. Get. And let's actually just grab the suborbital homepage. So do HTTPS //suborbital.dev. And this gives us an HTTP response. We'll do a .text on that to actually grab the text there. And then instead of returning this message, let's just, return this text. Let me go ahead and save that. Let's come back over here. Let's stop this. We'll rebuild it. We'll rerun sat and let's see if that works for us. So subo build dot webpack going. Good stuff. Making sure that we have this all built. We have our new WASM file. So we'll run sat again. And then let's come back over here and let's run that same curl command. And in this case, there's a bunch of HTML here. So I assume that this actually worked because it is the suborbital homepage. I imagine I'll find something in here that makes it seem like it's the suborbital homepage. Yeah, WebAssembly powered data plane. That's definitely the suborbital homepage. And actually, let's take a look at the suborbital homepage. On the suborbital homepage, there's this header here, the serverless engine to power your platform. That's pretty cool. Is there a way that we could use maybe some extra JavaScript libraries to help us do some parsing of this? And I think there absolutely is. So in fact, let's go ahead and install a package to do some parsing of this. So I'm going to do npm install. And there's a library called Cheerio. And so I'll install this library, and Cheerio is basically like a server-side jQuery implementation. But yeah, let's bring in this package. And in here, let's do import Cheerio. Only one R, please. Cheerio from, yeah, it's called Cheerio. So let's import Cheerio, and let's go ahead and get a handle to that. So we'll just do $, classic jQuery. And so we'll do Cheerio.load, and let's load up this text that we just got. So we have that here. And now instead of returning all this full text here, let's actually just grab that H1. So let's use our Cheerio object. Let's pass it, H1. We just want to grab that H1. And then the way that we get the text from that node is by calling the text function. And so with this, we should be able to load the HTML from, https suborbital.dev, send it to Cheerio, let Cheerio parse it, actually, grab this H1 here. So let's go ahead and build it. So subo build dot classic webpack again. Hopefully this actually works. It'd be really awkward if it didn't. But webpacking, Javi's all set, build our WASM file, same deal. Let's go ahead and run sat. And then let's come back here and curl it again. And when I do that, bam, there's our H1, the serverless engine to power your platform. So this H1 that's here, we've got it right here, which is awesome. And this sort of goes to show sort of more the reason why JavaScript and TypeScript inside of WebAssembly matters. There's an absolutely enormous JavaScript ecosystem of just different packages and things we can use that just don't necessarily exist yet for some of the other languages for WebAssembly. And by being able to run JavaScript and TypeScript inside of WebAssembly, we're able to just pull in a library like Cheerio or pull in other libraries. In fact, another really fun demo that we just put together, we did some server-side rendered React in Atmo. We had Atmo serving a server-side rendered React application, and that's absolutely awesome. And this isn't something we could necessarily do with some of the other languages for WebAssembly. And of course, there's a whole host of engineers out there that absolutely love JavaScript who want to use WebAssembly, but they're not necessarily comfortable with any of the languages that have first-class support for WebAssembly today. So by bringing JavaScript and TypeScript to these developers running inside of WebAssembly, we're really opening the doors for more and more folks to come in and start experiencing WebAssembly, even if, it's not, necessarily the easiest like little thing to do. It's very, very nice and accessible for all these folks. But yeah, I mean, that's about it for my demo, what we've been working on. This will be launching next week. So we're going to be super excited for everyone to start using it and giving us your feedback on how things are going for you. I know it was an absolute blast putting this together from both a code standpoint and from even putting this demo together and showing it all to you. So yeah, that's about it for me. I don't know if there are any questions that have come up, but if Flaki wants to come back on and let me know, that'll be awesome.
Yeah, absolutely. Also, maybe open the floor on the voice chat as well. How about that? Like, feel free to unmute on voice chat and ask any questions in there. I'm going to repeat it for the stream just to be sure, but like otherwise, you feel free to talk there. Or people are shy, but or maybe they're just too mind blown. I'm mind blown. I was just telling to chat that we're like, oh boy, like I wonder if you could like kind of load some library to like extract something like that, and like we were like, oh no, that would be just tempting fate. That sounds silly. Like no, we should just keep it simple. And you did it. Like that's like amazing. Like that was really really cool.
I mean, that's the power of this, right? Is, we have, like literally like millions, if not, I feel like there's even more, but literally millions of packages available on NPM of just all sorts of things that we want to do. And that's the other thing too. It's not like it's particularly slow. Even let's say, going back to Javi, this project uses Wiser. So it's not like a matter of like, oh, you have a whole JavaScript engine inside of your WebAssembly that must be so slow. Well, we pre-initialize that entire WebAssembly engine, that entire JavaScript engine, plus we pre-parse your code, we run so it's going to be completely ready the first time you try and execute that run function, right? And so there's not like a huge performance hit by doing this. It's sort of just, like for what it's worth, QuickJS actually is fairly quick. So it's been looking pretty nice so far.
No man is Owen, I guess. Yeah. I'm gonna quickly find there's a really cool video that you can check out from Nick Fitzgerald, one of the I guess the creators or like the of Wiser from WebAssembly Summit, and they presented like they introduced Wiser at WebAssembly Summit. I'm just gonna post that link in here. It's really really cool technology, and yeah, like there was a lot of cat herding, but at the end of the day, like a lot of this is building on. We did not build QuickJS or Javi or with BindGen, but like sometimes you have to like take all these technologies and glue them together.
Absolutely.
So there's definitely a lot of hair splitting behind all of this stuff. Oh, I see Denopink is unmuted. Does that mean Denopink has a question? Oh, he does. Yeah, so just to repeat the question for the stream and the recording. What is kind of the future of the ecosystem, and especially like how does debugging work in the Suborbital's future?
Yeah, absolutely. I think definitely, we want to continue to evolve this to be, even better in the future. We want to have, JavaScript and TypeScript be first class languages on the suborbital platform. The other languages aren't going away, right? You'll be able to use, Rust, Go, Swift, Grain, AssemblyScript. You'll be able to use all of these languages, that you love. But we just want to make sure that we do have rock solid options in JavaScript for folks. And even potentially in the future, more interpreted languages like Python or maybe even Ruby running inside of WebAssembly. Um, on the debugging side, that's like a fantastic question. And I don't think we have a ton of time, but one of the things for me to like sort of demo it, but one of the things that we cared about quite a bit was actually having decent debugging in terms of being able to use all these JavaScript runnables. So if an error occurs in your JavaScript, you do get a JavaScript stack trace, and it tells you, hey, this is what went wrong, like in this series of things. And we still need to do a bit of work there to continue to make it better, because right now, we aren't piping through source maps just yet, so we want to make sure that it's a little bit better. But it's definitely better than nothing. And having access to those stack traces was definitely helpful in terms of developing this and getting the initial version out the door, where I knew what was going wrong. It may not sound like it, but just knowing like cannot read properties like foo of undefined is incredibly helpful in trying to debug these things and get them working just fine. So yeah, debugging is definitely going to be an important part of the suborbital story. There's a number of efforts just in WebAssembly overall towards debugging and making that better. But specifically for JavaScript, we're going to try to make sure that we have really nice support with proper source maps and everything to help people, write code and feel confident in the code that they're shipping.
Yeah, also on the note of the future of the ecosystem and new languages, like the garbage collection proposal has been like blocked for a long time, and that is a very fundamental piece to the puzzle of adding like a lot of what we are doing here with QuickJS is kind of a hack in a way. I mean, it works really well compared to it, but it's still embedding a dynamic language runtime into your WebAssembly. So there's a lot of like performance gains to be won, like by integrating with your browser has a garbage collector, and like you could just use it. That would be cool. And so that proposal has just been unblocked recently and like moved further on the standardization process. So that is going to bring a lot of like as Oscar said, a lot of new languages, like more viable and more usable in WebAssembly.
Yeah, absolutely. Especially like as a language author myself, who has for a long time really wanted WebAssembly garbage collection to be a thing. I definitely agree with you. There's going to be a whole host of languages that we can have in WebAssembly that we couldn't have before, just because some languages can't necessarily just say, okay, whatever, we'll implement reference counting or something like that, right? So we're definitely going to see, I think, a huge explosion of languages that are available in WebAssembly as more and more of these proposals land.
Absolutely. Yeah. So again, the question was like basically the monitoring and observability in Suborbital, I guess, like supervision tooling. I don't know if anybody has a good point in that. I mean, Okay, so according to Connor, we're working on it right now.
Yes, it's definitely something that's in flight that we know that people care deeply about.
All right. I don't see any text questions besides that. We are beyond the hour, so we should be wrapping up. Last question, somebody? It goes once, it goes twice. Alrighty then. Thank you so much, Oscar. That was amazing. You should expect more information on all these projects, availability in Reactr, whenever we manage to cut the next release and stuff like that. And also like next week, stay tuned for like the mini release week. There's gonna be a lot of noise about some of these stuff. And thank you again for joining us for today's community meeting. Again, please send us your feedback. Please remember that we're waiting for contributors for docs, test drive our docs. Feel free to check out Subo or other open source stuff, and apply or show yourself if you want to contribute. And please join us next month at the last Tuesday. I believe that's March 26th, perhaps. March 29 for the next community meeting. So thank you again, everybody. Thank you again, Oscar. We'll see you next month.